The previous two videos in this module looked at modeling a queuing system, single server queuing system, where entities arrive, waited in line if necessary. When the server became available, they were processed and departed. And we built a sample path. We constructed an event calendar and built a sample path, and then analyzed that sample path for some performance metrics. In this module, we're going to expand our model into what's called a tandem queuing system. Where entities that depart the first server, which we'll call server 1, instead of leaving the system, they then go and are processed by server 2. And our objective for this module is to look at how we would construct the sample path and do modeling similar to what we did in the first two videos for the single server system. So recall the first thing that we did was identify the system state, and in our previous model we said that our system state consists of the number in queue and the number of servers busy, and that the NIQ value could take on any integer for 0 entities in the queue, 1, 2, 3, and so on, and that the number of servers busy would either be 0 or 1 for a capacity 1 server. So for our tandem queuing system, we need to expand that. So now we need to also track the number of entities in Q2 and the number of servers of type 2 busy. So what we'll do is we will just subscript the values. Oops, that's a 2. As so that now instead of having 2 components to our system state, we have 4 components. And so what we see in the model pictured is that NIQ has a value of 3, S1 has a value of 1, NB1 has a value of 1, NIQ2 has a value of 2, and NB2 has a value of 1. And so for example, let's say that server 1 finished processing the entity here, then the number in queue here would be 2, the number in queue here would be 3, reflecting the fact that the entity was transferred from server 1 into the queue for server 2. So that state representation is very similar to what we had before. We're simply expanding it to account for the fact that we now have 2 servers in series. Our next step was to identify the events that could cause the system state to change. And previously, when we had our single server system, we had an arrival event and we had a departure event. And with arrivals, the queue length could increase, or the server could go from idle to busy. And with a departure, either the queue length decreased, or the server went from busy to idle. So we can employ the same method that we did with the system state and just assume that we want to have a subscript here. So we'll just subscript arrival and departure. Arrival 2 and departure 2. And we could combine these 4 events, or we could create the system by expanding our events to include the second arrival and departure. However, as we'll see, we don't really need this second arrival event, because when we think about what happens when an entity departs server 1, it immediately arrives at server 2. And so the 2 events, departure from server 1 and arrival at 2, can be combined. And we'll process those under the departure from server 1. And so we will have events, arrival, we're just going to denote that ARR, departure 1, departure 2. Actually, I think in the previous video we called them completion. So let's maintain consistency here and just call this completion 1 and completion 2. So when an arrival event occurs, either the queue length will increase or the server will go from idle to busy. When completion on 1 occurs, then that entity will go to server 2. And so in effect what we're doing is we'll test to see whether the server is busy. If the server is not busy, it will become busy. And if the server is busy, then the queue length will increase. And so what we see is the completion, in addition to the previous logic that we had, which was to reduce the queue length on NQ1, it's also going to affect the queue in for the second system. So let's look at how this would work. If we built our event calendar like we did before, let's assume that we have the time, and then we have the event that occurs, and then I'm going to divide our sections into the state section, where we're keeping track of our system state. So we have our Q1 and server 1 and Q2 and server 2. So as we did before, we'll just graphically represent the entities that are either in the queue or being processed by the server. And then we'll keep track of the next events that are going to occur in the future. So we have our arrival event, our completion on server 1, and our, oops, I don't need a comma there, completion on server 2. And so this is the table that we'd like to construct for this example. So in our previous example, we used 10 entities. We're going to do a much smaller example this time, but we do need some sample data. And so the model we're going to use, we're just going to have 3 entities, E1, E2, and E3. And we need 3 pieces of information. We need the arrival time, we need the service time on server 1, and the service time on server 2, where previously we only had the arrival time and service time. Now we have 2 different server times. And our arrivals are as follows. We have 4, 5, 12. Service times on 1 are 2, 1, and 5. And service times on 2 are 3, 4, and 2. And so also note in this example, our first event doesn't happen at time 0. Our first event is going to actually happen at time 4. And so what we need to do is have some kind of initiating event to start the system, which we're going to have here at time 0, and we're just going to call this the start event. And at the time of starting the model, we have no entities in Q1, no entities being served at station 1, no entities in Q2, and no entities being served by station 2. Our first arrival, though, will occur at time 4, and we don't have any completion events because we have no entities being served. So we look at our current time 4, we look at our next events 4, and then no events here. So we take the minimum and we jump to time 4, and the event, of course, is the arrival of E1. When E1 arrives, it starts immediately in service. E1 is in service at S1. Nothing in Q2, nothing in S2. The next arrival, which will be E2, happens at time 5. Now E1 has started processing on server 1, so E1 is going to take 2 time units. It's currently time 4, so the completion will occur at time 6, and we don't have a completion on server 2. There's nothing being processed. So we take the minimum time for the next event, we jump to time 5, and time 5 is the arrival of E2. So now E2 is waiting in the queue, E1 is being served, Q2 and S2 are both empty. The next arrival, which is E3, will happen at time 12. Completion still happens at time 6. We don't have anything being processed on server 2. So the next event is completion on 1, time 6. This is completion on server 1. So let's think about what happens when this entity completes. The entity E1 will move from server 1 to server 2. So E1 will now be served by server 2. E2 will move to be processed in server 1, and both queues are empty. Our next arrival will still happen at time 12. Our completion on server 1 is now time 6, and we are just starting processing on E2, which takes 1 time unit, so this will finish at time 7. E1 has 3 time units on S2, and it's time 6, so that will happen at time 9. So now we have entities at both servers. We look at the next event. The next event is going to happen at time 7, which is a completion on 1. So we jump ahead to time 7. We have a completion on 1. And so what happens? Well, E2 has finished processing, and it's going to go to Q2 because server 2 is busy. So we have nothing in queue at server 1, nothing being processed at server 1, E2 has moved to Q2. E1 is still being processed. We still have 12. The next arrival happens at time 12. Completion on 2 happens at time 9. And we don't have a completion time for 1 because nothing's being processed. Next we go and jump to time 9, which is completion on 2. So entity E1 finishes, still nothing at Q1 or S1. Now E2 moves out of the queue into service. Our next arrival still happens at time 12. Completion on 1, nothing's being processed. E2 has just started processing on server 2, so it will take 4 time units. It's currently time 9, so this will occur at time 13. So now it's time 9. The next event happens at time 12, which is arrival of our third and last entity. So we jump ahead to time 12. That's arrival of E3. It begins service on S1. E2 is still being served. We no longer have any additional arrivals because we only are modeling 3 entities. The entity processing time at S1 is 5. It's time 12, so this finishes at time 17. And entity E2 finishes at time 13 as we had before. Next event happens at time 13, so it's time 13. This is a completion on 2. And so E3 is still being processed. Nothing in cert Q2, nothing in server 2. We don't have a future arrival. Finish processing at time 17 on server 1, and we no longer have a completion event on server 2. So now it's time 17. We have a completion on 1. Entity E3 begins service on server 2. We have no future arrivals. We have no completion on 1. Takes 2 time units. So at time 19, entity E3 will finish processing. We jump ahead to time 19, completion on 2. Nothing at server 1, Q1, nothing at server 2, Q2, no future arrivals, no future completion on 1, no future completion on 2, and so we have no more future events, and so at this point we can terminate our simulation. So now that we have our completed sample path, we can look at our performance metrics. In our single server model, recall that what we are interested in is the number of entities in the queue, the utilization of server 1. Those were our system metrics. Then our entity metrics were the time spent in queue and the time spent in system. So we have related metrics for our expanded model. We look at our entity metrics. We're still interested in the time in queue, but now we have 2 different queues. So we could model those separately, so the time in Q1, time in Q2, or we could add them together and model something like the waiting time. And we're also interested in the overall time the entity spends in the system. So as we did before, we can extract that information directly from the sample path. So we see that entity 1 arrived here at time 4, immediately started processing on server 1, so its time in Q1 was 0. It then transitioned to server 2 at time 6. So again, it spent no time in the queue because the server was idle when it got there, and then it completed on server 2 here at time 9. So it spent from 9 minus 4, or 5 units of time in the system. We can see that's what it should have spent. It didn't wait in either queue. It had 5 total units. So we can extract the information just as we did before. There's just a few more things for us to extract. From the system perspective, we're interested in numbering queue by queue. So we're interested in numbering Q1, numbering Q2. Now we have 2 servers, so utilization of server 1, utilization of server 2, and then finally number in system. So as we did before, if we wanted to, we could simply expand our table to include the system state that we would track as the system progressed. So we would have to have one system state variable for number in Q1, another one for number in Q2, one for the binary server 1 busy, the other for the binary server 2 busy, and then finally the total number in system. But other than that, other than the fact that we just have a few more things, the basic process would be exactly the same as we saw before. And you should definitely give this a try and make sure that you understand the details about how to do that for this example.